So for today, I want to talk to you guys about building software for the internet with Phoenix. Let's just get started. So yeah, I guess just briefly a little bit about me. I work for a nonprofit called Samasource. Also help out some community groups called, one is Les Pitonneux, which is like a group of people in Montreal teaching themselves how to code online. Montreal New Tech is a sort of another nonprofit in the city that kind of showcases like Montreal startups and gives them a little bit of a stage to show off their ideas for like a demo night once a month. I write software for the internet, so mostly at work I use Ruby for backend stuff and JavaScript for frontend stuff. More and more I am really enjoying working with Elixir, so I don't actually use it at work, so full disclosure, it's this kind of like side project type thing for me, but I find it a really fun language. So yeah, just briefly, I'm not sure how many people have ever heard of Elixir even. It's a functional programming language. It runs on the Erlang VM. So it's relatively new. It first appeared like around 2011, I think, but V1 was released in 2014. It was developed by Jose Valim, who is a Rails core contributor, allegedly out of his frustrations trying to make Ruby handle concurrent code well. It's gaining popularity relatively quickly, so it's used by some sort of big companies for some parts of their apps, including Pinterest is probably the most popular one. Moz, Bleacher Report, and Brightcove are using Elixir now in production, and that list is growing more and more. So it's definitely picking up speed. So like I mentioned, Elixir runs on the Erlang VM. So in case somebody hasn't heard of Erlang, it's also a functional programming language, but it's quite a bit older than Elixir. It was developed in the 80s by a telecom company called Ericsson for use in that industry. And there's quite a few companies that use Erlang for their apps. So Heroku uses it for some parts, RabbitMQ, and the really famous one is WhatsApp. You may have heard of this whole like 2 million connections on WhatsApp at a time. That's because of Erlang. Yeah, so last thing, sort of the main thing I'll talk about is Phoenix, which is a web framework written in Elixir. So it was written by Chris McCord, who's also a Rails contributor. Phoenix is a full stack web framework, so it means it comes with everything you need to build a web app, like front-end tooling and database abstraction layer. It's pretty similar to other MVC frameworks out there, model view controller frameworks. It doesn't really have models, same way other frameworks do, because Elixir is a little bit more of a functional language. But it's generally similar to like a Ruby on Rails or kind of like Express, or maybe if you know Python like Django. So yeah, Phoenix and Elixir are pretty new. But Erlang is really old, well, relatively, and has been well tested and well proven to be highly reliable and very scalable for big distributed apps. And so it's not too much of a leap of faith to trust Elixir and Phoenix. So yeah, like I said, I'm a web developer. I do mostly Ruby on Rails and some front-end stuff with JavaScript. And I haven't been doing it for that long, but I've noticed already that you quickly start to run into the same problems over and over again with web apps, and especially when you start to try to scale them. So building CRUD apps, which is, CRUD is like create, read, update, destroy, is pretty trivially easy now, thanks to all those awesome frameworks that I just mentioned. But as web developers, most of our time is spent building the non-CRUD-y parts of the app these days. So like all the stuff that lives behind the user interface where all the business rules live. And there are some fundamental challenges in web development because of the nature of the internet and user expectations in some ways that are sort of hard to solve. And Phoenix was built in a lot of ways to address those problems. And so that's kind of what I want to talk about. Yeah, and specifically how it's able to offer some unique solutions to these problems because of Elixir and ultimately because of Erlang. So yeah, just to kind of get started, web apps, one of the hard things about web development is that you have many different machines, or sorry, many different people asking for many different things from different places all at the same time. So some of your code runs on your server, and you might have multiple app servers running. Some of your code runs on your users' browsers. Some of your code might be running on some external services. And so even if you do only have one web server, web apps are distributed by their nature, because the code you write is running on many machines. They're also stateful. So a stateful app is one that changes as you interact with it. So like when you log into a website and then you visit another page, you're still logged in. Or if you add something to your cart and then you go to checkout, the thing is still in your cart. So that's kind of two fundamental properties of web apps, which sucks because both of these things are hard. So distributed systems are hard, and maintaining a valid, consistent state for like 1,000 or 1,000,000 or millions of people at the same time is hard. The real underlying problem is that you have stateful apps communicating over a stateless protocol, which is HTTP. So HTTP is stateless, just means every time you ask for a web page, you have to send all the information to the server to fulfill each request. So, and the flip side of that is that the server remembers nothing after it sends a response. And so every time you ask it for something, it's like it's the first time it's ever seen you. And once your server is done responding to a request, you probably load a bunch of stuff into memory to build up the response, but then it just throws it out. And every request that comes in is like a whole new thing. So to deal with these two properties of web apps, the first thing you have to do is make your server handle many things at the same time. So you have to do a lot of things for each request to build up the web page your user is asking for. And you probably also have a ton of people asking for different things at the same time. And so doing all these things at once means your code has to be concurrent. And also you have to somehow persist some state. You have to be able to remember things about your users between requests. So currently, a lot of the existing solutions, the solution is basically delegate to the operating system. So if you need your server to handle many things at once, say, like for example, in a Ruby app, you spin up multiple Ruby processes, and then you kind of punt the responsibility of making full use of your system resources to the operating system. This is okay. Operating systems are really good at context switching and managing processes like this. And because your code should have no global shared state, it doesn't really matter which process ends up handling which request, and so you just leave it to the operating system to schedule. For persistence, we typically use databases. So you offload all the state to a database, and then you transmit it back and forth from client to server with cookies. And this works as well. Databases are really, really good at persisting data and retrieving it efficiently. But then this adds complexity and also latency to your app, because you're constantly querying the database for information with every request. And what can happen is you have everybody trying to access the same database, so it can be tricky to maintain valid data in there. So this is sort of just a high-level idea of what a lot of web apps kind of look like right now. So like I said, you have multiple app servers, because a lot of times a single app server can only handle so many requests. Everybody's accessing the database, and then you have some sort of load balancer or HTTP server in front of them all. But because your code is stateless, and it doesn't matter which one of these machines responds to which request, this is a really trivial problem to solve. And then this is sort of how a lot of web apps are set up. So to scale this architecture, to scale this solution, because your server is stateless, you're getting stateless requests, you can just keep spinning up more processes to handle more requests. So that's fine, but then when your machine runs out of processing power, you can get a bigger machine. But then what happens when that machine runs out of processing power? You get more machines, and this just goes on. And it can be expensive, so it's not ideal. Also, it's sort of a solution that's built to accommodate existing programming languages and sort of the nature of databases more than an ideal solution for the web. So just to sum up sort of where we're at so far, web apps are distributed, highly concurrent. You have many people asking for many things at the same time. It's stateful. So this is a really familiar problem, actually. And in some ways, it's kind of been solved before, but just for a different kind of problem domain. By Erlang, not by Elixir. So Elixir is the new thing, and Erlang's the old thing. Yeah, so just to kind of explain how Phoenix is able to handle so many cool things, I'm going to talk just briefly, kind of as an aside, about Elixir's concurrency model, because it's really what underlies all of the cool things that Phoenix can do, and it's kind of what's behind everything. So Elixir's concurrency model is called the actor model if you're into computer sciencey stuff, and basically an actor is just a process, so or a thread, I guess. So an actor is just a super lightweight VM process, and in Elixir, anything can run in a process. So these are just created with spawn. This is like an Elixir shell. You can send messages to a process, and then you receive messages by pattern matching on like the expected message. And every process has its own mailbox. And so that is how you communicate between processes. Processes can only interact with each other by sending messages. So there's no other way to transfer information between processes in Elixir. So if you want to tell one process something, you send it a message. And that message can be async. And that message can also be like location transparent. So the process ID here that you're sending the message to can be on another node in your network. And so it's sort of best practice in, like, say, object-oriented languages to communicate like this by sending messages to each other. But the only thing forcing you to is really like good habits. It's really easy to be undisciplined and sort of reach into other objects that you're not really supposed to know about. But in Elixir, it's impossible. It's only possible to communicate by sending messages. So messages are sent asynchronously, which is sort of another difference. In object-oriented languages, typically, so you typically send a message by calling a method, and so that message is synchronous. And so you call a method, it does some things, and it sends you the answer, and then you continue execution. But here, like, you'll see so this is just gonna create like 1,000 messages that say, like, this is message number 1, 2, 3. And they're all sent asynchronously, so if you send them all at the same time, they come in like weird order. And they're read sequentially, which is the other key thing. So a process is like sort of a single threaded thread of execution inside of the Erlang VM. So all the messages in your mailbox are read in the order they came in, and one at a time. So a single process can read one message at a time. But you can have as many processes as you want, because processes obviously run concurrently. That's the whole point of the VM. So this is just going to have a bunch of delays, send a bunch of slow messages. So this is like we're going to fall asleep, but this could be any blocking I/O call, so like a slow network request if you're like calling an external API for something. And then we'll sit and wait around for the message. If you do this, so this is just 1,000, but it only takes as long as the slowest one. So the slowest one is going to be like 2,500 milliseconds. And if you send off 1,000 messages and then time it, it'll take only as long as the slowest one. And the last thing is sort of key is that memory is isolated to each process. So an Elixir process can make decisions about itself. It can change its own state. It can spawn more processes and send messages to other processes, but that's pretty much it. So it cannot reach into the memory of another process and figure out what its state is. The only way to communicate is by message sending. So that's sort of the actor model. And that's just sort of a super quick overview of processes, but then what if you need more? So like I said, the processes are just one-off threads of execution. So like what if you need to remember something between sending messages, or if you want to receive like exit notifications from one process. For maintaining state, there's a module called agent in Elixir. So an agent is just like a process that has a state. And so data is immutable in Erlang and Elixir as well. But you can maintain state inside of a process through recursion as opposed to mutation. So like you have some information, you do some things, and you call yourself with the new answer. And so like this, because processes are long running, you can maintain an internal state. And then for linking tasks together, so say like if I want to crash if that process crashes, or I want to know when that process is done doing the thing I asked it to do, there's task. So you can do all of this just with like bare processes with like spawn and send and receive. But a lot of the just sort of implementation details have been abstracted up a level for you by Elixir. If you need both of these things, if you want to maintain a state and keep track of processes, you can use a gen server. Just means generic server. And like any other thing in Elixir, it's just a process. So you can send it a message synchronously and say like, meaning I'm expecting a response. You can send it a message asynchronously as well, meaning like you don't care about the result. If you want to keep track of your gen servers, so like some people at this point we'll say like, well, you're maintaining state in a process inside this loop. What if the process crashes? Well, you can keep track of your processes with supervisors. So a supervisor is just a process that knows how to restart another process and also when to restart it. And so you can structure your app like this with like supervisor supervising something, and then that supervisor can be supervised, and then you get like a supervision tree, and then these nodes in your app, if one crashes, it sort of knows how to heal itself. So this is just like, these are just a few things that are included in Elixir and Erlang, and collectively, like all these things plus a ton of other stuff make up the OTP, the Open Telecom Platform. So the OTP is sort of just a bunch of like generic behaviors built on top of processes that kind of abstract away some of the implementation details of this like linking and monitoring and all these other things. And there's a ton of other stuff as well. It's not just about this, but yeah. So like I said, this ability to kind of just spawn as many processes as you want at the same time and keep track of them all really opens up some new possibilities for web development. So like I said, we have these two sort of like fundamental needs for a web app. They have to be concurrent and stateful. So instead of delegating your concurrency needs to your operating system and just spinning up a bunch of different like Ruby processes or whatever language you're using, you can leave that to the Erlang VM. So like this guy sort of mentioned, the Erlang VM is really, really good at scheduling all of these processes and passing messages between them super efficiently, and at like really making full use of your system resources. So that's sort of the exact like use case the Erlang VM was designed for, and it's really good at it. For persistence, you can use all the different things that are available to you in the Open Telecom platform. So there's solutions that can maintain state within a process. There's lots of longer lasting solutions as well. But basically, the OTP is like 30 years of iterating on best practices for maintaining state inside of fault-tolerant distributed systems. And so there's a lot of interesting alternatives that are possible. Yeah, so I just want to look at some common challenges. So these are sort of some like concrete examples of things that you might see in a web app, sort of a typical web app. And then some interesting ways that you can just offload that problem, and Phoenix can handle it in maybe a more elegant way. Yeah, so these are the problems. We'll just kind of go over them one at a time. The first thing that's super common, and one of the first things you run into when you start to try to scale a web app, is the requests become really slow. And so this sometimes is because, well, yeah, I guess how you fix them depends on what's causing them. So a common cause for slow web requests is that you're doing too much work within the request response cycle. So like I said, a typical web app, you have a request comes in and you do some stuff and then you send back the response. And if there's a lot of stuff happening in that interim, your client's just going to hang there and wait for a response. And so this is like if you have to do a big import or big export or building a big report or something like that. Typically, we solve this with background jobs. So that just means you like spawn another process. So this would like run in a separate, if it's on a Rails app, this would be a separate Ruby process. And it's just a worker queue running these jobs. So for one, this requires like some sort of external job queue. So if you're doing Rails, it'd be like Sidekick or Rescue or something. You have to pull that job to check on its status because it's not going to just tell you when it's done. And the other thing is all the jobs are still going to run sequentially in your worker. So you've removed this slow part from the request response cycle. But if you have a bunch of slow things queued up, they're still going to run one at a time. And so if you have like 10 people asking for a really slow report, the 10th person in line might be waiting like a really long time. In a Phoenix app, you can just solve this problem with Elixir processes. So it's kind of like a built-in way to handle the same problem. And like I said, this is all just like built into the Elixir library. You don't need any external queues or external dependencies. This task, you can say, so in Phoenix, every controller action runs also in its own process. And then once the response is sent to the client, that process dies. So if you run these asynchronously, and the no-link part says like, when this process crashes, so like the action is finished and the response is sent, don't crash the task. Just let the task keep running. Yeah, none of this requires like anything extra. The task module is a really key part of Elixir. Another really common cause of slow requests, again, usually when you start to grow, is like waiting on too many things. So for example, if you're doing like checkout in like an e-commerce app or something, you are fetching like a tax rate, some shipping rates, running through like maybe some fraud detection, reserving all these items. All this stuff takes a long time. And if you do like this would, you never see this in an app because these all run one at a time. So like external API calls are blocking. And so even if you're running things like concurrently, you're still, if you're doing any blocking IO, they're going to run one at a time. And so typically you would write some JavaScript probably to handle this. Writing things, so you would just send the response, render the page, and then on that page you would fire off a bunch of like AJAX requests to fetch these things. So it's not an ideal solution. For one, writing code like this with like callbacks and not really knowing the order the things are coming back in can be really annoying. So you probably never actually use just like plain JavaScript. You'd use like a library and stuff like that. But either way, you still have some other problems. Like for one, if you're doing this, you have to authenticate client side now with your APIs. There's all kinds of like complicated security problems with that. So a lot of solutions that do this actually go through like special endpoints on your server that are basically just gatekeepers. Like, so the server holds the API secrets and then the AJAX call calls your server. But then you end up with this like proliferation of endpoints that are just like gatekeepers. Also, the main problem with this, so those things are kind of like annoying, but they're not, I guess you could argue they're not real problems, but you have a real problem is that you can't really use this session now because if you have, so like I said, we transmit state using cookies. So when the response comes back, it sends the session state back to the client basically, and then clobbers the session. And so if you have like a bunch of AJAX requests coming in and you don't know which one's the right one, you can't reliably put things in the session. So yeah, you can do something similar to this server side as well, but the main problem is like you're dealing with callbacks now, which is annoying to maintain and hard to debug. So yeah, again, you can just solve this with processes. So in like a Phoenix app, if you wanted to do like 3 things at the same time, you can just do as many things as you want at the same time. You can tell a separate process to do that work. And so like in this case, if you care about the answer, you want to wait till you get the reply before you render your page. You can run these asynchronously, and then this task.await will just wait for the response. And these are like, if there's things UI doesn't care about, you can run them asynchronously again, and then just send the response and leave those ones to run. Yeah, so that's like the async part. If you're rendering a lot of things, so before, like typically you just have a lot of, like a big payload. If you're rendering a huge payload, either JSON or HTML or something, in a lot of web apps, you just cache things like crazy. So because typical web servers are stateless, you have to render the whole response every time. And so this can be slow, for one, if you're pulling data from a ton of places, but also if you're rendering a lot of things, like if you're on like a product index page, like here for example, and you have like a bunch of little product cards, and each card has a price and like an image carousel and some details and all these things. And so to reduce the load on your server, it's really common to just cache things like crazy, many different levels with like caching pages and caching fragments of pages because pages change for different users. And then you get like all the normal headaches that come with trying to deal with maintaining valid state, and you don't know if this invalid state is coming from your app or the cache or something. So in Phoenix, performance is not a concern. So you don't really need any sort of caching for capacity reasons. I didn't include any benchmarks because it's just they're everywhere. But if you Google like benchmarks for Phoenix, you'll see the performance is really unreal. So there's sort of, I guess there's a lot of reasons, but 2 of the main reasons. For one is that templates in Phoenix just get compiled to functions at compile time, obviously, instead of rendered at runtime. So and Erlang is just super fast at like executing functions, and so the way Phoenix handles rendering templates is a lot better. Also, Erlang is just super fast at string I/O. So putting strings together, like as opposed to storing a separate copy of each template in memory, it stores pointers to like the same pieces of immutable memory in the beam, and then it can handle putting these together really quickly to render your pages. So yeah, you don't need caching. So hey, I thought you said don't need caching, but still, in a normal web app, even if you're not caching for performance reasons, you probably have some need for some sort of like latency cache. So if you're doing like really expensive calculation or like calling a rate limited API, for example. So say you have some external service you're only allowed to call like 20 times a minute. You want to cache the response. So that's the type of caching I'm talking about here, not the type where you do it, not the type that you do for the reasons of like reducing the load on your server. Yeah, before, typically you'd use something like memcached. That's one particular example, but in general, it's like any shared high performance storage solution. So usually like some sort of key value store that's really, really efficient. That also runs on its own server. So now you need like another thing in your app and another thing to keep track of. Erlang, and well, in Elixir, you can use Erlang term storage. So also take this chance to mention, in Elixir, you can use any Erlang library just natively. So Erlang term storage is just a super efficient, like a constant time built-in memory store. And so it lives in a process, and so you have to think a little bit about maintaining the state of that process if it crashes. And so there's a little bit of maybe extra stuff to think about. But like I said, so this is just Elixir code, but you can use any Erlang library that you want. And so it's like they all just fit right in. OK, this one's fun. So sharing data. Yeah, your app has to be able to handle, obviously a lot of people trying to do different things at the same time. So for persisted data, you can piggyback kind of on your database's transactional memory and like wrap things in a transaction or something to make sure that the data in the database stays valid. But what about if you're sharing state inside your app? Like during a single request response cycle, you have stuff in memory. And the problem in a lot of languages is that things are immutable. And so right now, it's sort of up to you to just be careful. So this is Ruby. This is sort of relevant for any language that has mutable instance variables. So like if you're doing, this is like some class, you initialize it with some instance variables. And then if you pass this list of things to another class, now this class thinks it owns these things, and you might not get the thing that you expect. So this is unlikely, it's pretty bad practice, but you'll see this in like pretty much any Rails app at least. And it's really easy to pass things around like that without thinking about the consequences. And like this might also be like some library code that you don't own, and you probably didn't check what it does with that list of things. This is another really common one, like updating things in the wrong place. So you'll be like trying to deal with some weird bug and thinking like, why is this stock item marked as sold right now? And then you remember it's like, oh yeah, this class like 3 classes away, and this thing that's unrelated is updating it when this event machine like state machine thing fires or something. And so it's true, like this is bad practice, this is not good code, but it happens all the time. And the only thing keeping you safe is like really good habits. Another thing, so just briefly, where you have actual issues with thread safety, this is like less common. But if your app server is multi-threaded, which some of them are, like any operation that changes the state of something in more than one step can cause problems. And so, like I said, this is not really common. You probably don't see this much. But if you're dealing with any like threads in Ruby, you have to like manually lock things because they're not thread safe because they're sharing memory. So, and like this is the classic like counter one where you're like adding something and checking its value at the same time. So you get all these like weird race conditions. And yeah, like worrying about this stuff is like super annoying. It's like writing assembly when you could just write Ruby or something. So in Elixir, the data structures are immutable, like I said. So you don't have to worry about this whole thing like passing data around and worrying that something else will change it and like swap out the values from under you. And also memory is isolated to each process. So that's sort of the key thing, is that in Erlang, memory is totally isolated. And so you never have to worry about sharing state between processes. And then you still have like all the typical problems of maintaining valid state like in your database if you're using one. But for that, you can continue to rely on the shared transactional memory of your database and like wrap things in transactions. Yeah, so it makes for a much more pleasant developer experience, in my opinion, at least. Another example, things that sort of become a real problem as you grow, basically. Like the more people you have using your app, the more people you have using it in weird ways, and the more errors you get. And so a lot of times you don't really start to see holes in your concurrency model or in your business logic until you have a ton of people using it at the same time. And the main thing is you want to be able to recover from those errors, and you have to be able to handle them in a way that doesn't just ruin your app for everybody. So, and also a bonus if you can recover to a valid state, like a valid known state. And a lot of web frameworks, and yeah, typically now the strategy is sort of like just catch the errors that you can. So you think of things that might happen or things that might go wrong. Like for example, if you're uploading a file somewhere, you think, okay, well, what if the service times out, or what if S3 is down, or whatever, some other like expected exception. But like for one, if your code is running in a single process, so like typically a single process will process a whole request response cycle. If that process crashes, the whole request is ruined. Your user just sees like internal app error. And same for background jobs. If you're running like some things in a background job and one of the records throws an exception, then the whole job will crash, and now you have to like manually think about recovering and starting and picking up at the right place and all that stuff. And yeah, like I would argue, and like maybe sort of a controversial opinion, but like this is not really an error handling strategy, because if you knew all the errors your app was going to raise before you put it in production, wouldn't you just write your code to handle those cases? So anyway, the whole point of safe error handling is that the errors you don't expect are also handled well. And so in a Phoenix app, you can take advantage of supervision trees, which are part of the OTP and sort of part of what's possible because of Erlang, because of Elixir. This example is like really nothing, but you can spin up, if you have like important parts of your app, you can run them in a supervision tree. And so, sure, it's a lot to think about, but this way, if something goes wrong that you really don't expect, something that you didn't think would happen, you can continue. Your app will just keep working, and you don't blow the whole request. You don't lose like a ton of data, depending how you set it up. So yeah, so these are some things that are a lot easier or better to deal with in Phoenix than other web frameworks. So a lot of examples are from Ruby. That's what I work with, but it sort of goes for most of the kind of MVC frameworks that are out there. Yeah, as a bonus, in Phoenix, we talked about the performance for your users. It's super, super fast at fulfilling requests, but that also makes for a really good developer experience. So all the things that require that you boot your app, like running a test or running a migration or like booting a local server or something like that, are also really fast, which makes for a great experience if you're a developer. It comes with awesome dev tools like package manager and like front-end tooling and all this stuff, which is really nice. The other nice thing is it sort of really encourages separation of your app and your interface. And so something I didn't really talk about at all about umbrella apps, but in Elixir, umbrella apps are just pretty much exactly what it sounds like. You have an umbrella app with many little apps underneath it. And so you can structure your Phoenix app in that way as well. I guess Phoenix app is like the wrong term, but you can structure your app in that way. And then Phoenix is just one of the parts of your app. And so it's sort of easier to get away from this common thing that happens with web frameworks, where all the business logic is all like mixed up with all the framework code. And that's another thing that makes it sort of hard to scale an app. Yeah, and then the last thing is that it is highly scalable. So because it runs on the Beam, the Erlang virtual machine, for one, Erlang, like I said, is really, really good at scheduling and managing all these processes. So it can truly take advantage of a powerful machine. If you just get a machine with more cores, you can know that Erlang will actually be able to use them efficiently. And then also, you can also scale by just getting more machines. So because the leap from concurrent to distributed code with Elixir is a lot smaller than it is with a lot of other languages, because you already have all this infrastructure set up for supervision and keeping track of processes and stuff. Yeah, so it's not all awesome. There's obviously a few downsides. And I'm sure this list will grow. So the thing about Elixir and Phoenix right now is because it's sort of new, there's not that many people using it in production. it sort of seems awesome. And I'm sure like 10 years from now, as more and more people use it, we'll have a lot more presentations about the crappy things about Phoenix. But yeah, for now, at least, one of the downsides, at least from my perspective, is that you sort of have to change the way you think about like programming and web apps and everything. So for one, like Elixir is a functional language, and so there's that hurdle if you're coming from like a different like object-oriented languages or something. And basically to really take advantage of Phoenix. So like you can just use Phoenix and keep writing apps the same way you always did, and you'll still see a huge performance gain. But to really take advantage of it and to kind of explore new things and see what's possible, you kind of need to wrap your head around Erlang's concurrency model and the OTP. And this is like really confusing, at least for me. There's also, processing speed is not super great with Erlang. So if you're coming from, it's definitely faster than any interpreted language. So it'll be like a huge, it'll look like a huge jump if you're coming from like Ruby or Python. But if you're used to like a Go or Rust or something like that, you'll see it's like much, much slower. But it's not really meant for that. It's not meant for sort of number crunching type of things. Its concurrency model is really sort of what it's most useful for. There's also sort of a smaller ecosystem. Again, this is relative, but if you're coming from web development with a super popular framework, there's probably a library for everything. And it's to some extent just because it's a newer language, but also it's a little bit of like a different community, I think, in Elixir and Erlang, where it's like if something's really simple, you take the kind of most generic thing that has already been built for you, like in the standard library or in the OTP or something, and then you build your custom solution around that, as opposed to like always reaching for a library as the first kind of response to a problem. And and then also that is changing very quickly. So at first there were like not really any libraries for anything in Elixir, and you had to do like some really trivial things yourself, but there's more and more, and it's definitely becoming a lot more popular. So I guess that's pretty much it. So the main thing that I want people to remember is like Phoenix is more than just like yet another cool new web framework. It definitely is that, but you can also use it to solve some sort of like potentially really interesting like new problems. So this is kind of like the architecture of your app now. So instead of having all these like different app servers running and then a load balancer, and then I don't know if you're keeping track, but also all these other things that you want to accomplish require their own servers as well. Like you need a server for memcache, a server for your background job queue. You need probably Redis to maintain server-wide state. All of these things can be handled by just one Erlang virtual machine. And so sort of simplifies your stack and then opens up new possibilities. I don't know if anybody here is web developer really, but if you are, or if you build software for the internet, next time you need something, or even for some part of your app maybe, consider Phoenix, especially for things that require a ton of throughput. Because the request and response are super fast, it can handle more traffic than most apps on a smaller machine. Also with super minimal downtime, and that's also again thanks to the Erlang VM, because of the fault tolerance that you get with sort of the structure of your app. You can get like milliseconds per year uptime on Erlang. It's really good for real-time communication because you can potentially have a stateful server now. So that's the part that's also really exciting, is that typically web servers have always been stateless because of this kind of nature of the internet, but because you can have as many connections as you want to an Erlang virtual machine, you could potentially keep a WebSocket open for all your clients. And there's a ton of talks about like real-time stuff in Phoenix. So I didn't really include it in this one, but I guess that's pretty much it.